Hello everyone. This video introduces a TRINITY module, Virtualization of a robot cell with a real controller. The module is a component of the TRINITY use case, Virtualization of a robot cell with a real controller. Since the use case only has a single module, they both have the same name. The presented technology falls into the technical readiness level 6. So it should not be considered as a ready industrial solution. The purpose of this module is to demonstrate the possibilities of new technologies for improving the agility of manufacturing. In this video, we will present the purpose and intended use of this module, the structure and functionality of this module, the components and technical specifications of this module, and finally, the requirements and limitations of using this module. The purpose of this module is to create a separate sandbox environment for training and testing. The goal of this module is to increase the agility of a modern manufacturing cell by enabling the users to simulate production activities without disturbing ongoing production. The virtualization of a robot cell with a real controller is developed to help manufacturers train their employees and improve their production, and also for educational establishments to educate their students about agile manufacturing. The technology can be used during the whole life cycle of a manufacturing cell, from the proposal and sales phase to the commissioning and ramp up, and then to production and change management. It can be utilized as an interactive learning environment and a risk-free sandbox for testing and simulating production activities. The benefits of this module are improved agility and performance of the manufacturing cell. Valuable production time is not lost to training or planning activities, and improved employee competence and confidence. The system consists of two main parts: the control software, MMS, and the simulated hardware. The MMS, or Manufacturing Management Software, is Fastems' industry-leading production planning and execution software. It is used to drive the virtual model and acts just like it would with a physical system. The virtual model acts as the simulated hardware and replicates the physical manufacturing cell. Various parameters can be tweaked to create a one-to-one copy of the actual cell. The components interact with each other through a WebSocket connection. They exchange information about the current state of the cell, devices, and the robot. The control software sends transport tasks to the robot, and the robot will inform the control software once it has completed the requested transport tasks. In addition, updates to the part and pallet locations are sent to the cell to keep it up to date about any additions or removals. The manufacturing management software plans and controls the production activities. It automatically calculates the optimized production workflow and necessary resources based on orders. It adapts to changes in the daily production schedule and displays information to maintain the production output. It also acts as an interface between the human and the automation. The virtual model, on the other hand, acts as the manufacturing hardware of the cell. It executes commands given by the control software MMS. The virtual cell and its devices are configured to match the physical counterparts. The virtual model is run on the Visual Components platform. The system can be set up in two different ways: as a local installation or as a cloud installation. With the local installation, the MMS runs on a cell controller and is connected to the virtual model via Ethernet. With the cloud version, MMS runs in the cloud and connect remotely to the virtual model. Here you can see an example of a local configuration. In the middle you can see the Fastems cell controller, which can either be housed inside a touch OP, which is seen above, or it can be used as a standalone device. The cell controller is then connected to a network switch, which enables multiple PCs to connect to the system. The most important of these is the Visual Components PC, which is used to run the virtual model. It is connected to the cell controller via Ethernet. If there are multiple users, they can connect to the system via the network switch. Additional screens can be connected to the system to showcase the system to a wider audience. Finally, Fastems can provide remote support via the cell controller's internet connection. The same connection can be used by the user to gain remote access to the system. Now let's take a look at the technical specifications of the module. The cell controller has to have Windows 10 and MMS 7.1 or newer. This is handled by Fastems, so the user doesn't have to worry about it. The PC for the virtual model also has to have Windows 10 and Visual Components 4.2 or newer. The PC has to meet the minimum requirements for Visual Components. The current TRL of this module is 6. All of the previously mentioned features and functionalities can already be used. Eventually, the module will mature into a full-blown digital twin that will greatly improve the current capabilities of the solution. Finally, let's take a look at the requirements of the module. For local installations, the user has to have the virtual model PC and an Ethernet cable that they can plug into the network switch. For remote support, also Internet access is necessary. For cloud-based installations, only a stable Internet connection to the virtual model PC is required. Now we can conclude the presentation by summarizing the key points. The proposed virtualization of a robot cell with a real controller provides users with a safe environment for testing and training. It can improve the agility of a modern manufacturing cell by allowing users to try out production scenarios and train employees without disturbing ongoing production. This way, valuable production time is not lost, and together with the increased employee competence and confidence, it boosts the performance of the cell. The use of this module requires a PC for the virtual model and a way to connect to the cell controller. It can be installed as a local or cloud-based installation. If you got interested and would like to find out more, see the following training material.